Hello everyone, and welcome to the fourth and final recursion interview problem, the coin change problem. A quick note before we begin, this problem has multiple solutions, and it's actually a very classic problem, and it's classic because it shows some issues with basic recursion. So if you're having trouble with this problem, or it seems to be taking a long time to run in certain cases, really check out the solution notebook and fully read the conclusion link for a detailed description of the various ways to solve this problem. And then something to note, this problem is actually classic or common enough, it's famous enough that it actually has its own Wikipedia entry. So I've linked it here for you. So if you go ahead and click that link, it'll take you to the Wikipedia page, which is right here, and it says the change making problem. And it's a knapsack type of problem, depending on how it's asked. But you can go ahead and check it out here, check out the mathematics behind it. Probably don't check out the pseudocode until you've had a good stab at it yourself. Okay, so let's go ahead and look at the problem statement. In this particular version, what we're going to say is given a target amount n and a list of distinct coin values, or an array of distinct coin values, what's the fewest coins needed to make the change amount? So for example, if I say n equals 10, your target, and then coins, your denominations are 1, 5, and 10, there's 4 possible ways to make change here. You can have 10 ones, a 5, and then 5 ones, 2 5s, and 10. So the minimum amount of coins you need is 1 coin, that 10, that dime. Okay, so in this case, I want you to implement your solution below. Here, I just have a simple recursion solution set up, so it takes in that target and then that list of coins. Right now it has pass, but you pass in the target and the coins, and you'll get the minimum amount of coins used. It should be noted that there's other versions of this problem that ask you different things, such as instead of asking what's the minimum amount of coins, they may ask you how many possible ways are there to make change. So they may be looking for this answer, 4 possible ways, instead of the minimum amount. Right now, we're focusing on the minimum amount because of its implications of dynamic programming and memoization. So the reason this is the last recursion interview problem is because it's one of the tougher ones if you approach it through a straight recursive mindset. You should really think about dynamic programming and memoization. So again, note the test cases here in this test cell is only going to test with 2 parameter inputs, the target and the list of coins. If you decided to use some sort of cache and that's a 3rd argument in your solution, this clearly won't work because your solution here, as far as the test cases, is only going to take in 2 arguments. So if your non-dynamic function is taking a long time to test and you believe you have a solution, you should go check the solution notebook instead of really running this cell. All right. So again, best of luck. Remember to read the solution notebook for this once you think you have a solution. In the next lecture, we'll be discussing a notebook. It's a lot to read, so it's going to be a last homework assignment for this recursion section to fully read the Wikipedia entry and the entire notebook that really dives into this coin change problem. Because this is actually going to serve not just as an interview question, but a real learning example of dynamic programming, memoization, recursion, and really wrap up this section in a great way for you to learn everything we've learned in this section. So really go over all those topics. Okay, so that's it. Best of luck with the coin change problem. Once you think you've had a good stab at it and have your own solution, go ahead and go to the next lecture where we're going to discuss and go over everything we learned in this section. All right, thanks everyone. Best of luck.